On the shark bite, which numbers do we want to see? Do go over, had questions on. Majority 5s, 2s, and 3s. So those are going to be the ones we do. Sorry for anyone else. Alright, for number 2, going back to translating. So remember I told you that each of these shark bites is going to be like a mini SOL, covering whatever we talked about throughout the year. So translate the following and solve. So the quotient of, so everything after this is going to be using the quotient, which is dividing a number more than, so this is going to be your variable, more than is plus 1 and, that's where we're going to be dividing 3. So we're going to have a fraction, x plus 1 over 3 is 5. That just means equals 5. So that's the translating part. Then it asks us to solve it. So then we are actually going to solve it, get x by itself, by multiplying both sides by 3. We have x plus 1 equals 15. Subtract 1 on both sides, so that we get 14. We were to put that back in. 14 plus 1 is 15. 15 divided by 3 is 5, so it works. Questions on that one? Do you have a question? Number 3, also previous material evaluating. So we're going to put x and y into all of the x and y's. So we'll have negative, in parentheses, negative 12 outside of the parentheses squared, minus 3 times negative 5, 6 times negative 12. And then start to simplify. So I'm going to do each piece. So this would be negative 144 plus, because this is going to give us a negative, positive. This would be 15 over 6, or 5 halves, times, negative 12. If I multiply these two together, I would get negative 60 over 2, which would be negative 30. And then if I combine these two, negative 172. Questions on that? 2, 3, and number 5. So number 5 was our word problem. So this wants to send a package to a friend in Spain. I don't actually have friends in Spain, but it costs $3 for the packaging and 20 cents for each ounce. If she paid $15.60, how heavy was the package? So you need some variables, call that x, for ounces. For number of ounces, we know the total is 1560, and we would be adding 3 plus 0.2x, and then we could solve. Subtract 3 on both sides. And divide both sides by 0.2. Someone tell me what that would be? 60. 60. That will be all wrong. So make sure you are defining the variable, set up the equation, solved it, and got the answer, and put the label. Any missing pieces will get you down points. Right. Questions on that one? Make sure your name is on your answer sheet and go ahead and pass those up. So back tables, pass them up to the table next to you. Jacob, can you collect them from the table behind you? Donovan, from the table behind you. So one will be dropped, the rest will be stored as it is. But for the next time, just hold on. And then that's
Three.
So stupid. It's negative 174.
like the short that we did last time. On your desk, you have multiple things. One is a set of notes. We'll come back to that. A course calendar and a review book. So let's talk about the review book first. That is yours to keep track, do with whatever. It is for extra practice. So that will be helpful for the next few units. There are different things in there from, actually I think there's word problems in there too. So if you're still working on retake process, you can work through those as well. So from last unit, from this unit, next unit, a couple more units in that. So feel free to use that for practice. Feel free to come see me with any questions you have on any of those things. Look at your course calendar. Okay, so this is basically same as last time, pacing-wise. On the 27th, so in a couple weeks, you'll be taking the quiz on this unit. On the 31st, the following week, will be the test. Because that leads up to when the quarter ends, all of this stuff will be put on quarter 2. So when I send out reminders or messages, emails about looking at your grades, missing work, all of this stuff that does math, the quizzes, the test will be on quarter 2. So that also means your grade right now will be your grade for the end of the quarter unless you retake. So you have 3 weeks to do so. Tuesday, Wednesday, Thursday, every week after school. The last day to do, I'm looking at the board right here. I wrote it up here just in case you forget. It's also on every Canvas announcement between now and the end of the quarter. The last day to do retake work is the 1st. So that's in 3 weeks on a Wednesday. After the 1st, so on the 2nd, you could take retakes, but you're not doing retake work. So if you come see me on Thursday, but you haven't done your retake work, you're not retaking on that last Thursday. I also wouldn't wait until the last week because everyone waits until the last week, and then I get busy, and then you don't get seen or get questions asked, all those things. So come get that done as soon as possible. Remember that you can do Delta Math, the additional practice at home, but you can also come see me with any questions you have for retake process. But keep those 2 dates in mind. The 1st is the last day for retake work. The 2nd is the last day for retakes / missing Delta Math work. Now you could come see me for Thursday for Delta Math on this stuff, but not from previous. Right? Questions on anything end of quarter, this unit wise? Okay. So then on to your notes. Some of this stuff will be familiar to you, some may not be. We're going to cover it all like you may have not seen it before. So today's notes is going to be on slope, which was covered in middle school, but if you don't remember, that's okay. I'm going to have you guys take down some notes. So on these notes, I'm going to read through them as you are writing these down. Our topic is slope, which is similar or can be interchanged with rate of change. It is a ratio that shows how one variable changes with respect to another. On a linear graph, this is called the slope of the line. So slope and rate of change can be interchanged. Slope is written as a ratio of the vertical change, the rise, to the horizontal change, the run, between any 2 points on a line. This remains constant for any 2 points on the same line. That means between point A and point B, the slope is the same as point B and point C and point D, and so on and so forth. Slope is written as a fraction in simplest form, and the variable for slope is m. I'm also going to have you write or draw in these axes and these forwards. We're going to draw in what these look like and talk about them. So as you're writing those down, I want to kind of give you something to help you remember. So slope is rise over run. A way to help me remember that is I think about when I get up in the morning. I sit up out of bed, so I rise before I actually get out of bed, so I rise before I run. You think about it like that. Make sure you have these words as well, positive, negative, zero, undefined. Okay. And then I'm going to draw in what these graphs are going to look like. Does anyone still need anything from this one? Alright, positive. This doesn't have to look exactly like this, but try to make it look similar. It's going to look like that. Negative is going to be the opposite. Zero is going to be a straight horizontal line. Make sure you're drawing arrows at the ends of these. Undefined is going to be a straight vertical line. So when we are thinking about our slopes, we have to think about directions. If we have a positive slope, the direction, so if I'm looking at this left to right, my rise, I keep going up, and I'm going to the right. Up and right are both positive directions, so if I have a positive over a positive, I'm going to end up with a positive. But I could also look at it the other way. So let's say I'm going right to left. Well, my rise is technically going down now, and I'm going to the left. Down and left are negative directions, but if I have a negative over a negative, I'm still going to get a positive. So either way, you get a positive. Negative is the opposite. So if I'm looking left to right, my rise is going down first, and then to the right. So I have a negative over a positive, which ends up as a negative. Or the opposite, if I'm going right to left, my rise is up and left. So a positive over a negative, which ends up still being negative. Questions about those before we continue? All right. With zero, our rise, are we going up or down at all?
No.
So we're not going up or down at all, but we are moving left and right. But 0 divided by anything is what? 0. So no matter what, this will always be 0. No matter where the line is, as long as it's horizontal, it's always going to be 0. For undefined, we are rising, going up and down, but we're not moving left and right. So pick a number, your favorite number, divide it by 0. In the calculator. See what happens. What do we get? You get an error. We cannot divide by 0, at least in this class. In calculus, they divide by 0 all the time. But in this class, we cannot divide by 0. That is undefined. You get some error. This is undefined. On the side, under the finding slope on a graph, you can write rise over run, but I also want you to write this and leave some space. HOY VUX. Hoyux. These are going to be words that we remember throughout the year. stands for horizontal lines have 0 slope and are y equals. And then the opposite is true. Vertical lines have undefined slope and are x equals. So this is going to be a really good way to help you remember which type of line has what type of slope. So horizontal lines have 0 slope always. Vertical lines have undefined slope always. Alright, now let's find the slope on these graphs. So, to do so, you need to find points on the graph that cross the grid lines exactly. There may be points plotted, there may not be points that you have to find. So give me points that you see, ordered pairs, that are plotted on this line that cross the grid lines exactly. Say that one.
2 up and 1 to the right of 1 for the bottom.
So -2. Are you talking about this one?
Yeah.
Okay, so -2 and -2. That's the problem.
It's like 2 up and 1 right from the down.
You need the order. What's the x, y value?
0, -1.
So 0, -1, negative.
Isn't it y first? Sorry, -1, 0.
So for your order test, so this one's not quite on the line. It's close, but not really. It's like super close, but not quite. But this one would be -2, 2, -2, -2. So when you're looking for your ordered pairs, it's x and then y. All right, give me another one. Another ordered pair point that you see. You're close, it's 5. So now we have 2 different points. Now we're just going to count. So it doesn't matter, let's say we start at this point, we're going to count our rise first, how far we go straight up. You don't need to do this, but if it helps you visualize, go for it. So we're going 7 up, and then from that point, how many over? And since we're going 7 up and 4 to the right, and those are both positive directions, our slope is going to be a positive 7/4. Okay. I'm going to also show you that this works from the opposite direction. So instead of going up and right, let's say we started at this point, but we still have to do rise over run. So we're going to go down. So we'd be going down 7 and left 4. Which would be a -7 over a -4, but that would still simplify to be a positive 7/4. So it does not matter which way you look at it, as long as you're doing rise over run and not run over rise. All right, questions on number 1? Let's try number 2. Give me 2 ordered pairs. Four, 2. Okay, one more. Five, -5. 5, -5 would work. Okay, so let's count that slope. Let's say I'm starting at this point. My rise, I'm going down 3 units. And how many units to the right? 9. So because we're going down 3, that would be a negative 3 over 9. But we can also simplify this to what?
Negative 1 over 3.
Negative 1 over 3. That means every time I go down 1 and to the right 3, there should be another point. So let's check that. So from the original, down 1, right 3, there's another point. Down 1, right 3, there's another point. If I could keep going off the paper, off the graph, it would keep doing that all the way to negative and positive infinity. Right? Same thing would happen if you did it the other way. You would end up with the opposites signs, directions. But when you write your final answer, you want the negative either in the numerator or out front, not in the denominator. So even if you started off with the denominator, put it in the numerator or in the front. Okay. Questions on 2? So we're going to do the work for 3 and then show you that you don't need to. So give me 2 ordered pairs on number 3.
1, negative
1, negative 1. That wasn't one of the given points, but it is a point on the line. That crosses the grid lines exactly. Sure. So in this case, I'm not rising at all. The distance between those two is 2. But it doesn't matter because it's always going to be 0. So you could count the rise, count the run for these different lines, but you don't need to if you remember that this is always going to be 0. So you could just say n equals 0, there's really no work, you don't need to count anything like that. So then what would the slope for number 4 be?
0. Oh yeah, undefined.
Undefined. Do we have questions on how to find the slope from a graph? On to the next page. We're going to go over any questions you have, want to go over first, and then I'll let you practice some, and then we'll move on. So on this page, 7 through 21, are there any questions we want to see you go over, have questions about? And there are lines at 9 and 12. You may need to outline them. Is that what you said, Pat? 13. For number 13, give me the order pair points. The order pairs that you see. Zero, positive 2. Over here. Or negative 2 if you're talking about. Any other points? At least one more. One right here. You're right. This is a number here. So this is not the 13 you're looking at. You're looking at this one. But 2 1s still would not be the point you're talking about. So that would be right here. Right here. So what would be another point? Do we have that one? 0, 2. What's the other order pair? Haven's not the only person in this classroom. -3, 1. Right here. Oh wait, no. 1, -3. There we go. So for your order pairs, make sure you're going x, y. Slope is y over x, but order pairs is x, y. Right, and then if we're counting our rise over run, let's say we're starting at this point, we're going straight down. How far did we go down? 5. And then how far did we go to the right? 1. So if we're going down and right, is that a positive or a negative? Negative. And we can simplify that to just be -5. So that means every time I go up 5 to the right one, up 5 and to the left one, or down 5 and to the right one, I'm going to end up at a slope point. It'll be off the graph for this one. Any others on this page? Alright, so I'm going to give you 5 to 8 minutes to do as many of these as possible. Some of you already started. And then we'll go over any questions we have and move on to the next thing. As a reminder, for every single problem, you should have equals m or m equals. You should be simplifying for every single problem. Okay. If no questions, go on to the next page. So I know some of you started these already, and that's fine. Make sure you have this formula at the top. M equals y2 minus y1 over x2 minus x1. This will be something you will need to remember, but I will say that if you switch things a bit, it's okay. So in that sense, I mean, let's say you forget, does 2 come first, does 1 come first? If you switch these two, it's okay, as long as you switch the x's as well. So if I switch it, so it's y1 minus y2, if I have x1 minus x2, it's okay. You'll get the same answer. You will not get the same answer if you only switch one of them. You'll get a positive instead of a negative, or vice versa. What also cannot be switched are the x's and y's. Y's have to stay in the numerator because of your rise over your run. Rise is y's, are your y, whatever. And your run is your x, are your x's. So keep those in mind. If this helps you, you can do this. If you don't feel like you need this part, you don't need to do this. So to help me distinguish which one is which, I label. So these are all ordered pairs, x1, y1. xy, so I label them x1, y1, x2, y2. And then I use those to put them into the formula. So 3 minus 1 over 4 minus 1. And then we simplify. So 3 minus 1 would give us, what's number 2? And 4 minus 1 will give us 3. And then we put equals n. And that's what. So that means if these 2 points were on a line, on a graph, every 2 over 3, every time we go down 2, or down 2 and left 3, or up 2 and right 3, we end up at another point on this. Alright, let's do a couple more. So same thing for number 2. x1, y1, x2, y2. We'll have negative 2 minus 4 over 10 minus a negative 2. So we are always subtracting no matter what. But if there's a negative, you also have to include that. If you would like to change the 10 minus a negative to a plus, you can. But don't just go changing things to plus just because. Because plus isn't in the formula. So if we're simplifying this, this will be what? At the end, negative 6 over 12, which would simplify to be negative 1/2. Okay, so always simplify if possible. Same thing with the negative that I said before. Make sure it's in the numerator or out front, not in the denominator. We're going to skip a couple of these and go down to number 5. Do we have questions so far? So for number 5, we're going to do the same thing. x1, y1, x2, y2, 9 minus 9 over 3 minus 5. What number should we get here? 0 over 3 minus 5 would give us negative 2. Still show this work, but this would just be 0. So if you see a problem that looks like this, where the y values are the same, your slope is going to be 0. You still need to show the work for it, but that would help you identify that this is going to be a 0 slope. All right, let's try number 6. We have 5 minus 8 over negative 7 minus a negative 7. When we subtract, we get negative 3 over, and anything dividing by 0 is undivided. So again, if we see that the x's are the same, we're going to get undefined. Okay. Do we have any questions on how to find slope from 2 points in general before we up it up? So now let's try number 7. Same process, but now we have fractions. You may want to do this on a separate sheet of paper so you have more space, or maybe like turn your paper to the side so you can write in this space. So start off the same, your y2 3/4 minus 2/5 all over 1/3 minus 2/3. But now we have to combine the fractions or simplify the fractions, but we can't do that until they have similar common denominators. So the bottom, the denominator fraction have a common denominator. You could go ahead and subtract that. But the numerator fractions do not. You have to get these to be the same. So think about a number they both go into. That 4 and 5 both go into 4 and 20. So I could multiply 4 by 5, but what I do to one piece of the fraction, I have to do to the other. And multiply 5 by 4, so that I'm changing both of those fractions. I'm going to leave this like this for now. So we have 15/20 minus 8/20 over 1/3 minus 2/5. Now we have common denominators for everything. So we can subtract just the numerators. So 15 minus 8 would give us what? 7. 15 7/20 over -1/3. Now this still does not look nice. We don't like fractions within fractions. We talked about that previously when we were simplifying. So to get this out of this format, we're going to take this denominator, we're going to flip it, and we're going to multiply it to both the bottom fraction and the top fraction. So that way when you do this, the whole denominator fractions cancel, and you can just multiply across to get what? -21 over 20. That means if I were on a graph, every time I go up 21 and to the left 20, or down 21 and to the right 20, I would end up at another point. Or if I figured out what that was as a decimal, I could do that. It's a lot. It is a lot. What questions do we have on that process before we try one more? After we do the next one, I'm going to show you how you can do some of it in the calculator. Some of it you saw for sure what I worked for. So number 9. These are mixed numbers. We have to change the mixed numbers to improper fractions before we can do everything we just did. So as a reminder, or if you forgot, to change this back to an improper fraction, multiply the 2 and the 3, the bigger 2, and the denominator of 3, and then after you get that number, add it to 2. So this would be 6 plus 2 is 8/3. I'm just going to rewrite this for now. And then multiply by 2, add the 1, so 8 plus 1 would be 9. Keep the denominator the same. If you wanted to double check that you made the correct improper fraction in your calculator, we could put in 2 2/3, which I did earlier. So alpha y equals, but instead of going into the first one, going to the second one. Put in the fraction. If you hit enter, it changes it to an improper fraction. So still alpha y equals, but instead of the first one, the second one, put it in, hit enter. Great. Now we have fractions in improper form, and we can begin our process. So we're going to have 9/2 minus 1 over 3 minus 8/3. We have to get common denominators. Your whole numbers are really over 1. It's invisible. We don't see it, but you have to remember it's there. So that way we can multiply this by 2 and this by 2. Multiply this by 3 and this by 3. So we're going to change the whole numbers to fractions. We have 9/2 minus 2 over 2. All over 9/3 minus 8/3. Then simplify. So what would our two fractions be? Seven halves and 1/3. And then that last step, take the bottom denominator fraction, flip it, multiply it to both pieces. So that our final answer is 21/2. If it was 22/2? Yes, but that would not.
But like, are you allowed to
You need to change it to a decimal?
like if it was simplifiable?
Yes. If you could simplify it more, yes. But this one cannot be. Okay. Questions on that process? So I'm going to show you how you can put this into the calculator, but you have to be very careful with this, so I won't do exactly what I do. Go into alpha y equals, go into the first one. In your fraction bar, in the top, hit alpha y equals again. And then scroll all the way down to the bottom and hit alpha y equals again. It should look something like this. If you did not do exactly what I did, your fraction bar is going to be off. And then you can put in the two fractions we had. 7/2 and 1/3. And then it should give you that answer. So if you get to that last step and you simplified it all the way down to this, you could put this into the calculator to get this part, or you could do it by hand. But if you don't put it in like that, it's going to divide weird and not give you that same answer, so you got to be careful. So these problems, you should be taking it slow, taking it step by step, because it's very easy to miss something, do something wrong, get a wrong piece somewhere, and then your answer be wrong. All right. Questions on calculator, any of that? Yes.
My calculator gave me a different answer.
That's probably because you didn't do exactly what I said. So alpha y equals. At the top, do it again. Alpha y equals. All the way at the bottom, do it again. Alpha y equals. So yours probably looks something like it could be a mixture of things. So it could be like this, it could be this part down here, something like that, where I see this is the bigger fraction, and all of this is divided to this, or this is divided to this part. It has to look even. Okay. I want you to try 8 and 10. Compare your answers to the people around you. Work together if you so choose. I'll give you some time to work on that, and then we'll come back and talk about the answer. So for number 8, you should have 2/5 minus 3/5 all over 2/3 minus 1/2. If you subtract this first, that was fine. If you waited till they were both common denominators, that was also fine. One way to do this, there are multiple, is to make this 6. So I'm going to go ahead and subtract this top part. So that we have negative 1/5 over 4/6 minus 3/6. Negative 1/5 over 1/6 would be your fraction. And then whether you did that part in the calculator or by hand, you would take it and flip it. So that your final fraction would be negative 6 over 5. Questions on that one? And then for number 10, you have to take these and change them first. So this should have been 3/2. And then the other one should have been 49/8. And then you could have continued 49/8 minus 2 over 3 minus 3/2. Get common denominators by multiplying these by 8 and this by 2. So we have 49/8 minus 16/8 over 6/2 minus 3/2. Subtract everything, boys in the back. And then either put this part in the calculator or flip this and multiply. So 11/4 was your final answer. Questions on that one? Basically, if you can do this problem or anything like it, those are the hardest slope problems. You can do all the slope problems if you can do this one. Right? For the remainder of class, you can be working on, you have a Delta Math not due anytime soon, it's due on the 27th, but there is one, that way you're not waiting until the 27th to do all of them. You can keep working on slope practice. On the very back, there are 3 more fraction problems. So on the back of all of the pages, there are 3 more fraction problems at the bottom. There are practice pages up here on slope from a graph and slope from points. These do not have fractions on them. But you have 3 different things you can be working on. Choose one of those and work on those.